Hello friends, today I am giving a presentation on the topic of addressing modes of 8086. We know that 8086 is an IC known as the general purpose microprocessor. Now what is the addressing mode? Addressing mode indicates a way of locating data or operands. Depending upon the data types used in the instruction and the memory addressing modes, any instruction may belong to one or more addressing modes, or some instruction may not belong to any of the addressing modes. Thus, the addressing modes describe the types of operands and the way they are assessed for executing an instruction. Here today we will present the addressing modes of the instructions depending upon their types. According to the flow of instruction execution, the instruction may be categorized as sequential control flow instruction and control transfer instructions. So we are now today studying about the sequential control transfer instructions. These are the 8 different addressing modes like immediate addressing mode, register addressing mode, direct memory addressing modes, register based indirect, register relative addressing modes, base indexed addressing mode, relative based indexed addressing mode, and implied addressing mode. Now we will discuss one by one. The first is immediate addressing mode. What is this type of the instruction mode? In this mode, the operand is specified in the instruction itself. It means instructions are not longer, but the operands are easily identified. For example, MVICL 12H. It means the data or the operand, which is our 12, it has to be moved immediately in the count lower byte register. The next is register addressing mode. In this mode, operands are specified using registers. This addressing mode is normally preferred because the instructions are compact and fastest executing of all instruction forms. Registers may be used as source operands or destination operands or both. For example, you can see here move AX BX. It means whatever the operands or the data in the B register, that has to be shifted to the accumulator. The next one is direct memory addressing modes. In this mode, address of the operand is directly specified in the instructions. Here only the offset address is specified, the segment being indicated by the instructions. For example, move CL 4321H. Now you can look here that the specified address is offset address is specified in a square bracket. So whatever we have to write the offset address, we have to use here the square bracket. So the instruction moves data from the location to the data segment into the count register. So the physical address is calculated as a data segment into 10H plus 4321. It means suppose our location is 4321 and our data is in the data segment location, so we have to multiply it by 10, so we will get the data stack pointer at the 5000H and the program accumulator will be 50,000 plus 4321, that will be 54321H. So these locations data will be transferred to our count register. The next one is register based indirect addressing mode. In this mode, the effective address of the memory may be taken directly from one of the base register or index register specified by instructions. If registers is source indexed, data indexed or base register, then DS, which is the data segment, is by default segment register. If our base pointer is used, then stack segment is by default segment register. For example is given here, move CX BX. It means This instruction moves a word from the address pointed by bx and bx plus 1 in data segment into count register CL and CH respectively. Physical address can be calculated as DS into 10H plus BX. The next one is register relative addressing mode. In this mode, the operand address is calculated using one of the base registers and an 8-bit or a 16-bit displacement. For example, move CL BX plus 04H. This instruction moves a byte from the address pointed by bx plus 4 in data segment to CL. So in the CL, what will be the transferred? It will be transferred as the data segment bx plus 04H. Physical address can be calculated again as ds into 10H plus bx plus 4H. The next one is base indexed addressing mode. Here operand address is calculated as base register plus an index register. For example, move CLBX plus SI. SI is the source index here. This instruction moves a byte from the address pointed by BX plus SI in data segment to CL. CL, what should be uploaded in the CL now? That will be the DS A plus BX plus SI. The next one is relative based indexed addressing mode. In this mode, the address of the operand is calculated as the sum of base register, index register and 8-bit or 16-bit displacement. For example, move CL BX plus DI plus 20. Here BX is the register, DI is the data index register plus 20. This instruction moves a byte from the address pointed by bx plus di plus 20h in data segment to CL. Again, the physical address can be calculated as ds product of 10h plus bx plus di plus 20h. And the last one is the implied addressing modes. In this mode, the operands are implied and are hence not specified in the instructions. For example, STC, this is the set the carry flag. Now CLC, to reset the carry flag to 0, increment, decrement. These are the another examples of the implied addressing modes. I hope you can understand now. Thank you.